video, we are going to focus on the different types of variables. Let's go over them one by one. So the first type of variable is what we refer to as qualitative or categorical variables. As the name implies, when we say categorical variables or qualitative, these are attributes or characteristics that are in terms of categories. So one example would be sex. Sex is a qualitative or a categorical variable. It's because it's composed of two categories or two groupings. Okay, that's a male and then a female category. And we have the second type of variables. We have what we call quantitative or numerical variables. So these are characteristics or attributes that are in terms of counts or measurements. So here, if we are talking of numerical values, okay, so that type of variable now is what we refer to as quantitative. And furthermore, there are two categories or two types of quantitative variables. So the first one is what we refer to as discrete variable. Discrete variables use the process of counting to generate data. So another name for discrete variable is also referred to as count data because the values are generated by having to count them. Okay, and we keep in mind that these values of attributes are in terms of whole numbers because when we count to generate these values, the values that we may that these may take on are only whole numbers. Okay, so for example, the number of t-shirts owned. So how do we determine the number of shirts or t-shirts owned? So we count it, okay, using whole numbers. All right, and we could not say the number of t-shirts would be 3.5, okay, because that 0.5 there will not make sense. Okay, so that's why the number of t-shirts owned would be a discrete variable. That's because we generate the values by counting, okay, and we end up with whole numbers only. All right, and the second type of quantitative or numerical variable is what we call continuous variable. And here in this case, it uses the process of measuring to generate the data. So continuous variables are also referred to as measured data. Okay, so take note, for discrete variable, the values are generated by counting them. Thus, we refer to it as count data. Okay, however, for continuous variable, the values are generated by having to measure them. Okay, thus, continuous variable is also referred to as measured data. Okay, so these are attributes or values of the attributes may have fractional or decimal parts or decimal values. Okay, so the moment the variable is generated by measuring them and you end up with fractional values or decimal values, you may not always end up with whole numbers. Therefore, that type of variable or that type of quantitative variable is continuous. Okay, so for example, say age. Say the age of the person is 12.3 years old. Okay, so in that case, age there is a continuous variable. Okay, now we will proceed to the different levels of measurement. Okay, so may it be we have a qualitative or quantitative type of variable. Okay, there are corresponding levels of measurement for each type of variable. So when we say measurement, it is the process of assigning numbers to the observations. So we have four different levels or scales of measurement. Let us go over them one by one. So the first one is what we refer to as nominal level. Okay, so this is consists of numbers which indicate categories for purely classification purposes. So here we take note that the categories must be mutually exclusive and exhaustive. So what do we mean by that? Let's take the following for example. Say sex is composed of the male and the female categories. So here we code or we denote the male category with the numerical value, which is 1, and the female category with 2. Okay. However, take note that the values that we use here for 1 and 2 would simply to name the categories that we have. So the moment you are coded as 1, then that means to say you belong in the male category. If you have been coded as number 2, then you belong in the female category. Okay, however, we take note that these numerical values, however, do not follow a certain degree or ranking or hierarchy. Okay, so I can interchange this actually. So I may denote one for the female category and two for the male category. Okay, that's because the numerical values that we have here do not indicate a certain ranking. Okay, however, they are simply used to denote the different categories that we have. Okay, and we here by the statement that the categories are mutually exclusive and exhaustive, that means to say if the individual belongs in this category or in this group or in the male group, then he could not belong in the female group. Okay, in the same manner, if the individual is categorized to be female, then she could not belong in the male category. Okay, that is what we mean by mutually exclusive and exhaustive. So meaning, if I have 50 participants, okay, then the total number of those belonging in the male category and the total number of those belonging in the female category must also sum up to 50. Okay, so that is what we mean by mutually exclusive and exhaustive. Okay, so we take note that the numerical values that we use here is simply to denote the different categories, and they do not represent a certain ranking or hierarchy. Okay, because the moment the codes that we use or the notation that we use for each category would follow a certain ranking or hierarchy, then that is now in the second level of measurement, which is what we refer to as the ordinal level. So ordinal level here, they possess rank order characteristics. Okay, the categories must still be mutually exclusive and exhaustive, but they also indicate the order of magnitude of some variable, and precise differences between ranks do not exist. So in this case, for example, right? Say the Likert type scale. So I know you have encountered or you have been asked to or requested to do online surveys or even surveys that are done on paper. Okay, and then you have encountered certain items wherein they ask you to rate your level of agreement, for example, in certain items or in certain statements. So that is what we refer to as Likert type scale. Okay, so here one may be used to denote strongly agree, two for agree, three for being indifferent, four for disagreeing, and five for being in strong disagreement with the statement. Okay, so the numerical values here would follow a certain ranking or hierarchy. So the lower your score, meaning to say, the stronger is your level of agreement. However, the higher the score or the higher the value, then that means to say you have higher degree of disagreement with the statement. Right? So let's have another common example for the variable to belong in the ordinal level. Say, for example, um, let's say let's take for example size of t-shirts, okay, or sizes of shirts. So we have the small, medium, and large. Right, so we still have categories. Okay, however, the groupings or the categories that we have there would actually follow a certain ranking, okay, or ordering. So large is bigger as compared to medium. In the same manner, it's bigger as compared to small. Okay, so as a medium sized shirt is smaller than large, but it is bigger than a small size. So the different groups that we have there would follow or would belong in this level. So it is ordinal level. Okay. So we go back the moment we have qualitative or categorical variables. Okay. And if the categories do not follow a certain ranking, then meaning to say they are in the ordinal level of measurement. However, if the categories that we have would follow a certain ranking or a hierarchy, okay, or ordering, then it is in the ordinal level. Okay. Now we proceed with the third level of measurement. So we have what we call the interval level. So it has all the properties of the ordinal scale, and a given interval or distance between scores has the same meaning anywhere on the scale. And intervals provide information about how much better one value is compared with another, and it has what we call no absolute zero. Okay, so what do we mean by it has no absolute zero? Okay, let's take for example, say temperature. Okay, temperature in degrees Celsius, and here temperature in degrees Celsius is in the interval level. Okay, how is that so? So let us consider this characteristic. It has no absolute zero. Okay, that means to say, if the temperature in degrees Celsius is 0 degrees Celsius, in that case, it does not mean that there is no temperature. Okay, there is temperature. And the 0 degrees Celsius indicates that the temperature there is actually the freezing point. Okay, so that is what we mean by that there is no absolute zero. So the zero that we have for the degrees, the temperature in degrees Celsius, okay, would indicate that there is a temperature, okay, and that corresponds to the freezing point. Okay, so that is what we mean by it has no absolute zero. Okay, so let's have another example. Okay, let's have this. Say IQ. Okay, so IQ here is in the interval level. That's because there is a meaningful difference between an IQ of 110 and 109, but the test does not measure people who have no intelligence. Okay, so we keep that in mind, right? Now let's proceed to the fourth level of measurement. And the fourth level of measurement is what we call a ratio level. So it possesses all the characteristics of the interval scale. However, now, the main difference with the interval scale is that it has what we call a true or absolute 0 point. Okay? And the ratio of two values is meaningful. For example, say distance. Say the distance I travel from my residence to school is 0 kilometers. Okay, so that what we mean by having a true or absolute 0 point. The 0 kilometers indicated there would actually mean that I did not travel. No displacement occurred. Okay, so it will indicate that I am residing in the campus or in the school. Okay, that's because the distance that I travel from my residence to school is 0 kilometers. Okay, so there is what we call now a true or absolute 0 point. So the zero that we mean would actually mean zero. Okay, another example. Say number of students in a classroom. Okay, so is it possible for the number of students in a classroom to be equal to zero? The answer is yes. Okay, so we have what we call a true or absolute 0 point because when you say zero number of students in the classroom, that would indicate that there is no or there are no students inside or in a classroom. So the zero would actually mean zero. So there is what we call a true or absolute 0 point. So this is the main difference or how we distinguish a variable which is in the interval level or in the ratio level. So it has something to do with having a true or absolute 0 point and with no absolute 0 point. So the moment there is a true or absolute 0 point, then that type of variable is in the ratio level. However, if there is no absolute 0 point, okay, or no true 0 point, then it is belonging in the interval level. Okay, so I hope the different levels of measurement is clear to you. Okay, now we have what we refer to as analytic goals. Okay, so these are the things we have to keep in mind the moment we formulate our objectives or our statement of the problem. So what is our goal? Okay, what do we intend to achieve? Okay, what questions do we need to answer? So these are directed toward finding out from the data one or more of the following attributes or characteristics of the group being studied. Okay, and the first analytic goal is what we refer to as central tendency. Okay, so basically, it covers the general characteristic of the group. Okay, and for example, let's have the following objective. Say you would want to determine the mean weekly allowance of USLS college freshmen for the first semester of academic year 2020-2021. Okay, so in this case, we are talking of the mean or an average. So when we talk of the mean, it's a measure of central tendency or location. So if you can recall, in senior high or even in high school or in junior high, there are three different measures of central tendency or central location. So we have the mean, the median, and the mode. Okay, so if you are determining the mean of a given set of data, okay, that you have gathered, then you are talking about the general characteristic of the group, okay, and that is the central tendency. Okay? Another example. Say you would want to determine the percentage of USLS college students who would prefer an iPhone over a Samsung cell phone. Okay, so we are talking of percentage or proportion. Okay, so you will get the percent or the percentage of those who would prefer an iPhone and those who would prefer Samsung. Then you do the comparison. So in this case, you are or your goal is the general characteristic of the group. Okay, and that's something to do with percentage, right? And that is belonging in the central tendency goal. Okay? Now, let's proceed to the second goal. Say variance in the group. You're interested with the variance in the group. So here you are interested with how individual members of the group vary from the average characteristic of the group. Okay, so recall we have different measures of variation. Okay, so we have range, which is basically the difference between the highest and then the lowest value in your data set. Then we also have the variance, okay, and we also have what we call the standard deviation. So those are different measures of variance or variation. Now let's take the following example. Say you would want to determine the age range, okay, of the students in statistics class. So when we talk of the range, as what we have pointed out earlier, it is simply the difference between the highest and then the lowest value in your distribution. Okay, so if you would want to determine the age range, so basically you are referring to the variance in the group. Okay, another example. So you would want to determine if the statistics final grades of the students in a particular class would be similar. Okay, so when you say similar, then we mean to say they are consistent or the values are close to one another, or how varied the distribution of the grades of the students in statistics. Okay, so your goal here is to determine the variance in the group. Okay, let's have the third one. The third one is what we refer to as the difference within the group or between groups. So here, whether or not subgroups of the group or two separate groups being studied are different or similar on certain traits that are being investigated. Let's take this for example. Say you would want to do the comparison now, okay? Not just merely computing for the mean, but the moment you have computed for the mean, then you do the comparison. The moment you do the comparison, then you are, or your goal is to determine the difference within or between groups. Okay, so in this objective, you would want to compare the mean number of Coke Sacto bottles consumed in a week between the male and the female USLS students. So in this case, you are comparing the average or the mean number of Coke Sacto bottles that the male students would consume in a week. In the same manner, you take the mean number of Coke Sacto bottles that the female students or USL students would consume in a week, and then you do the comparison. So if you do the comparison between these two groups, your goal now is a difference within the group or between groups. Okay? Let's have another example. Okay, so here, say you would want to determine if there is a significant difference in the mean number of text messages sent in a day among the students from the 5 different colleges of the university. Okay, so in this case here, there are 5 different colleges. So these are your 5 different groups. Okay, and you are interested with the mean number of text messages that are sent in a day of those belonging in the 5 different colleges. And you would want to determine if the differences between or among these colleges would actually be significant or not. Okay, so in that case, here your goal is to determine the difference within the group or between groups. So take note the moment you are doing the comparison between groups, okay, regardless of the characteristic, okay, or the numerical characteristic that you are trying to investigate, okay, as long as you are doing the comparison between two or more groups, then your goal there would be the difference within or between groups. Okay, let's have the fourth one. Say relationships within the group. So here, if relationship between certain variables are covered in the study would exist. Okay, let's have the following example. So you would want to establish if there is a significant relationship between choice of cell phone brand and the college a USL student belongs to. Okay, so you would want to determine if their choice of the brand of the cell phone, okay, would be linked to the college where the student belongs to. Okay, so you would want to determine if they are related or not. So if that is your objective, then meaning to say your goal there is to determine the relationships within the group. Okay, let's have another example. So you would want to determine if relationship status and final grades in statistics are said to be independent. Okay, so you would want to determine here if the final grades of the students is not related to relationship status, or if they are related to each other. Okay, so if that's the scenario, then your goal there is to determine relationships within the group, right? And then the last is what we refer to as prediction. So here you are trying to establish a mathematical or a statistical model to predict future outcomes. Let's have the following example. Say what factors influence, okay, the graduates, just take note of this typo, the graduate's ability to land a job within 1 year after graduation. Okay, so for the ability of the graduate to land a job after, within 1 year after graduation, or what factors would actually determine that? Okay, so here, which factors would predict, okay, the ability of the graduate to land a job within 1 year after graduation? So your goal in this case is prediction. Let's have another example. Say, what is the estimated sales of a particular restaurant for next week if the present conditions would hold? Okay, so given the present conditions of the restaurant would remain constant, okay, how you would want to determine or you would want to predict, okay, the sales of the restaurant for next week. Okay, so here your goal is prediction. Okay, so take note that there are 5 different analytic goals, may it be central tendency or variance in the group, okay, or the third one that would be difference, okay, between or within groups, and the fourth one would be relationship, okay, and the fifth one would be prediction. Okay, and here there are actually 2 types of analysis. Okay, so depending on how you would want to interpret, okay, the values or the data values that you have gathered. So here, the type of analysis involved is descriptive the moment you are limited to simply describing the particular group that is being studied. So here, a conclusion cannot be applied to cases which is outside of the group that you are studying. So you are simply limiting your interpretation or your conclusion based on what you have gathered. You do not go beyond what you have gathered. Okay? Because the moment you do, then you are now dealing with what we refer to as inferential type of analysis. So based on the outcomes or the result of the data that you have gathered, okay, application of the findings or conclusions from a small group or what you have gathered to a larger group or what we refer to as your population from which the smaller group was drawn. Okay, so you make use of the results that you have gathered from a smaller group, extending it to a bigger population, okay, to find out if this population would exhibit similar properties. Okay, then what is involved there is inferential type of analysis. Okay, and that will be the end of this part of the module for our discussion. Okay.